in this practical is we want to determine the degree of hydration of a hydrated salt. In other words, we want to work out the number of water molecules present in a particular hydrated salt. So that's what we start with. We start with a hydrated salt. In this example, we're using hydrated sodium carbonate, but we don't know how many water molecules are bonded to the sodium carbonate. So what we want to do is we want to measure out and make up a solution that we know how much of the hydrated sodium carbonate that we started with. We want to make up a solution, and what that will do is it will cause the water of crystallization, the waters that are bonded to the sodium carbonate. It will cause that those to break off from the sodium carbonate molecules. And then what we can do is a titration to work out our number of moles of sodium carbonate in the solution, and then we can work out the mass of the sodium carbonate within the salt. From that we can get the mass of water and work out our ratio in order to determine the degree of hydration, a calculation that you've done before. So we're going to take you through the practical of this experiment now. I'm going to demonstrate it for you, and hopefully we'll get a chance to try this at some stage as a class. So the first step of this practical is to prepare a solution that is really accurately known, and that we know the mass of the sodium carbonate that we started with, the hydrated salt, and we know the volume of water that we've put into it. That will allow us to do our moles calculations and so on. But it's really important, the very first step is that we weigh out an accurately known mass of the salt. You can see that it's a white solid at the minute. That's because it's a group 1 salt, and group 1 salts, group 1 compounds are always white solids that dissolve in water to give colourless solutions. So you can see the white solid now, it's like a crystalline solid because it's hydrated. But when I weigh it out, I need to know exactly the mass that I have in my solution, and that will allow me to do my calculations. So what you might be told, if you were asked to do this in a practical exam, asked to make up a solution from a solid, it might ask you to measure out accurately approximately, say, 2.5 grams. And what that means is that it doesn't have to be right on 2.5 grams, but it means that you need to know the exact mass that you've got. So say, for example, it was 2.52, that's okay, as long as you write down it's 2.52, as long as you know that's the mass that you've put in. So in the example in your notes, the mass that we're asked to measure out is 2.86 grams, so that's to 2 decimal places, 2.86 grams. So what I've got here is a mass balance, and it's important that it is to the degree of accuracy that I need to measure out. So 2.86 grams is to 2 decimal places, so I need a 2 decimal place mass balance, and that's what we have here. This is just simply called a weighing boat. It's just a plastic boat that we can then dispose of. When I put that on the mass balance, you might not be able to see the numbers clearly in the video, but obviously that's going to put the mass up. That's 2.75 grams. So what I can do is just zero the mass balance so that I can measure out my 2.86 grams of my salt. So I've got the sample here in a small beaker, and I'm just going to use a spatula to measure that out accurately. So that's just 0.34 grams, so I know I need a good bit more. You want to make sure you don't get any on the metal part, the top pan of the mass balance, because that will take into account that mass, but it won't be in the sample that I've measured out, so I need to make sure I do that accurately. So still a bit to go. And when you're getting close to the amount, you should add it a wee bit more slowly. I've gone over, actually it's 2.96. So I'll take a little bit out. And I can do that because this was clean. I probably wouldn't put it back into the main bottle of the chemical, but since this is just our sample, I can take a little bit out. Okay. And again, if the question said, you know, accurately approximately 2.86 Right now it's at 2.87 grams, so I could just say, okay, that's close enough to what they have asked me to approximately measure out, but as long as I record that that is the mass that I've used. But because the practical actually tells me to measure out 2.86, we'll go for that. So that is it, right on 2.86 grams now. So that's the first stage, although now it's gone up to 2.87. Sometimes even with a little bit of movement of air past this, it can change mass. So we'll take a tiny wee bit out. And that's us back on 2.86 grams now. So I know I've got the exact mass that's measured out. So that's the first step, measure out accurately your known mass of your salt, because we want to know how much salt we're putting in our solution in the first place. So now that I've measured out my accurately known mass of the hydrated salt, I want to make a solution of that salt. In other words, dissolve it in water, and that will cause the water of crystallization to break away for those bonds between the sodium carbonate and the water molecules to break, so that we can then work out our number of moles of sodium carbonate in our titration. So in order to make up a standard solution, again, we've got to be really accurate about this. I know that I've got 2.86 grams of my sodium carbonate in the weighing boat, and I want that to all be in my solution. If it's not, if I leave a little bit behind, then I actually don't know the concentration of my solution. So a lot of this process is making sure all of that gets into the volumetric flask. And then from that point, we can make it up to an accurately known volume by filling it up to this mark. Now, you might not be able to see that in the video, it's a very faint line, but volumetric flasks are very accurate pieces of apparatus. They allow us to know the volume of the solution very accurately. So we're going to make it up to 250 centimeters cubed. So in order to do that, I need my salt of accurately known mass. I need a beaker, a stirring rod, my volumetric flask, and some distilled water. So the first thing is that I take my salt from my weighing boat, and I want to put that in a clean, dry beaker. It needs to be clean because we don't want anything else in it that might interfere with our experiment. And we need it to be dry so that we're not adding any tap water, for example, which contains ions that again could interfere with our reaction. So first things first, I'm just going to pour this in to my beaker, okay? But as I said, I need to make sure all of that 2.86 grams makes its way into the volumetric flask eventually. So what I need to do is I need to rinse this weighing boat because there could be a little bit of the solid left behind. So I'm going to just rinse that carefully. Rinse the inside, again with my distilled water, because ultimately this distilled water is going to then make up my solution. Okay, so that has been rinsed now. I can set that aside. And you can see that my solid has started to dissolve. It's not enough water to make it all dissolve yet, but it has started to dissolve and it will make a colourless solution. So the method in your notes then says add approximately 100 centimetres cubed of deionized or distilled water. We just don't want to add more than 250, and we don't want to add, we don't want to add that much yet because we will make that up accurately in the volumetric flask. Really what I'm doing now is just adding enough water to get my salt to dissolve in the first place. We want it to be dissolved before we put it into the volumetric flask. Because we won't be getting our glass rod and stirring it in the volumetric flask. We do that in the beaker. So I'm going to do that using my stirring rod, but it's really important that you're accurate when you get to this stage. We don't take our stirring rod out until after we are finished the practical, until we're finished making it up in the beaker and stirring it. And that's because when we start with the glass rod, ultimately there's going to be a bit of the salt on my glass rod, and even if it is the solution will contain some of my sodium carbonate, and again I want to make sure all of it makes its way into the volumetric flask. So I will stir with my glass rod, but at the end I will take it out and rinse that, but we'll come back to that in a second. So what I want to do at this stage is I'm going to add about 100 centimetres cubed. Don't need to be accurate at this stage, so I'll just pour a little bit in from the bottle up to about the 100 milliliter mark. Okay. So I'm going to get my glass rod and I'm going to stir to try and get this all to dissolve. But remember, at this stage, I don't want to take my glass rod out until it's all dissolved. And when I take it out finally, I will then rinse it with the ionized water. So the thing with this, again, I'm leaving the glass rod in there so that none of my solution ends up out of the beaker. The thing with this practical is that sodium carbonate can produce a cloudy solution. Sometimes actually the anhydrous one provides a clearer solution, so it may be a wee bit cloudy, that's okay, but what we want to do is make sure there's no solid particles at the bottom. So I'm going to stir this and just make sure it all dissolves. Now that our salt has all dissolved, we want to make up our solution to an accurately known volume in our volumetric flask. So you'll see my salt has dissolved, but I have not removed my glass rod from my beaker yet, because remember, on that surface it has got some of the solution which will contain some of my dissolved salt. So as I remove it, what I want to do is get my deionized water and just rinse the glass rod so that all the solution that is on the glass rod is in with the rest of the solution in the beaker. So as I remove it, I'm just going to rinse it down. Just swirl it a wee bit to make sure that it's all got in there. Okay, and I don't put that back in because otherwise it'll just pick up more of the solution. So I can just leave that off to the side now, and that's absolutely fine to do that. And what I want to do now is transfer this solution into the volumetric flask. And I do that using a filter funnel just to make sure that I don't spill any of it and just it all gets into the volumetric flask. Because remember, I want to get all of my sodium carbonate into the volumetric flask. So put the filter funnel in, okay, and pour that into the beaker. Or sorry, from the beaker into the volumetric flask. Okay, what I then want to do is I want to rinse the inside of my beaker with deionized water, just in case there's any of my solution which contains any of my salt in that in the rest of the beaker. Swirl it round a little bit and add that to the volumetric flask. That's what we call add it with washing. So in other words, that is washing the inside of the beaker. And we can do that again just to make sure, just in case any of it is still around the edges of the beaker. Okay, so add that to the volumetric flask. So at this stage, we've managed to get all of the salt from my weighing boat into the beaker, making sure I rinse the weighing boat. And then we want to make sure we get all the salt from the beaker into the volumetric flask, and by washing it as well to make sure that we've got everything from the beaker. But now some of our solution will be on the inside of the filter funnel, so we need to rinse that as well. And not forgetting that we also rinsed our glass rod as well. So we want to rinse the inside of the filter funnel in case any of my solution is there. And then we will take that out. Okay. So what we want to do now is make up our solution up to the 250 centimetre cube mark so that I know the volume of the solution accurately. I will then also know the mass of the original salt, so I'll be able to work out its concentration, or how many moles of our salt we have in there. So what I do is I just add more deionized water from my bottle, and I'm going to make it up to this mark. So you can just add quite freely until we get to the neck of the volumetric flask. Once you then get to the neck of the volumetric flask, you need to start being a little bit more careful and adding a bit more slowly, because what we want to do is make sure the bottom of our meniscus of our water level is on that line. That is, when it's on the line, we know that we've measured, we've made up our solution to 250 centimetres cubed. As I mentioned before in a previous video, if you go slightly over that, you have to start again, because it's not like we can just take a little bit out, because that little bit we've taken out will contain some of our salt, our dissolved salt, so we cannot do that. So we sort of add drop-wise towards that, that mark, so we've got to be really careful at this point. So what I'm going to do is I'm going to zoom in and show you that, so you can maybe try and see the mark a little bit better, and we can see it getting up to that level. So what I have here is my volumetric flask, which is nearly filled with water up to the mark, but I just wanted to zoom in and show you that making up to the mark. It maybe seems a little bit random, but I have put the recycling bin behind it. Just it allows you to see that mark a little bit more clearly. So hopefully you can see just here we have our mark, and that allows us to see when the solution has been made up to 250 centimetres cubed. So I want to add water until it gets to that point, and then we will mix it. But as I said, we need to be really careful at this point, because if we go over, then we need to start again. So I'm going to add a little bit more just straight from my bottle of deionized water, and then I'm going to start adding drop-wise. So you can see at this point it fills up quite quickly. So we want to be really, really careful. My nerves start getting to me at this point, because I think if we had to do this again, it would be quite a lot of work, but we would manage, I'm sure. So what I want to do now is I'm going to take off this lid, and I'm going to add it just using a dropping pipette. You may notice this is a wee bit wet. I'm going to just squeeze a little bit out onto some paper towel there. I just rinsed it through with deionized water just in case it had been used with anything else. So I rinsed it a few times with deionized water. So that's absolutely fine. It's not containing any other chemical. So what I want to do is get down at eye level and just add drop-wise, allowing the water to flow in from the edges. And a little bit more. So the meniscus is that sort of curve at the top surface of the water, and we want the bottom of it to be sitting right on that line. So we don't look at the edges of the water, we look at the bottom of the meniscus. So I know you can't see me in this video, but I am crouched down so that my eye level is at that mark. We're not far off. If you, again, not sure what you can see in the video, but if we were to look at the top of the curve, the top of the meniscus, it's sitting on our line now, but we want the bottom of the meniscus to be sitting on the line. So we're just a drop or two away now. And I know this probably seems quite tedious, but if we're going to do our calculations at the end of this practical, we need to know how much of our solid is in the solution and the volume of it accurately. So looking at that at eye level, the bottom of the meniscus is now on the line, and so I'm going to leave it at that. So now that I've added water so that my level, the bottom of the meniscus, is sitting right on the mark, I know that I have a solution that is exactly 250 centimetres cubed. So what I do at this stage is I stopper my flask and I invert it and shake it a few times, just to make sure that my solution is of an even distribution, that all of my salt has dissolved, and that there's none sitting at the bottom. You can do a quick check to see if there's none sitting at the bottom. Just a few times is absolutely fine. And then we'll just leave it at that. Now, sometimes when you do this, the level of your meniscus can appear slightly below the line, and that's because some will be on the walls of the top of the neck of your volumetric flask. So if I have a look now, it's hard to see that line actually because it's a wee bit bubbly at the top. The bottom of the meniscus is actually slightly below the line. That is absolutely fine. You do not then add a little bit more in, because as I said, there'll be some coating just the inside of the top of the neck, and that will flow down eventually. There might be some around the lid of the flask. That's okay. It just means that if I was to pour this out, I might not get all of my 250 centimetres cubed. It's not all sitting in this part, but that volumetric flask in total contains 250 centimetres cubed of my solution, and if I was to add any more water, I would affect the concentration of my solution, which I definitely don't want to do. So that is how you make up a standard solution. It's a long process in some ways, as you get practice in it, you obviously get quicker in it, but it's something you need to take your time with and be really accurate, because as I said, we need to know the mass of our solid in this solution accurately, and we need to know the volume of water in it as well. So what we're going to do now is we're going to take this solution and we're going to take part of it out, and we are going to titrate it in order to work out how many moles of sodium carbonate I have in this solution. So now that I have my standard solution made up in my volumetric flask, I'm ready to do my titration to work out how many moles of sodium carbonate I have in this solution. So my titration apparatus is set up and ready to go, but I want to prepare it now. So I'm going to be placing my sodium carbonate solution into my conical flasks because I don't know the concentration of that solution. And then I'm going to be titrating it against a strong acid, hydrochloric acid of concentration 0.1 molar. So that's going to go into my burette. So what I'm going to do now, but I'll speed it up so that you don't have to watch all, I don't know how long it's going to take me, how many minutes of it. I'm going to place my sodium carbonate solution into my 3 conical flasks for my rough titration, my first accurate, my second accurate, and I'm going to fill my burette with hydrochloric acid.